Okay, so today we're going to talk about percent yield. So with percent yield, you need to know that you have your actual yield over your theoretical yield times 100%. So what is an actual yield? An actual yield is the yield or the amount of a product collected from a chemical reaction. Your theoretical yield is the mathematical calculation of how much you should actually have during that. Now, do they always equal? No. One, in actual yield, we have some reasons why they wouldn't. First off, human error. You measured things wrong. You didn't let the reaction run long enough. You just have some simple errors. We never see, maybe some of the product got stuck to the side of the container that it was in. There are tons of reasons why your actual yield will not be the same as your theoretical. Now, it should always be a little bit less than your theoretical. That would still be a good product. Now, if your actual yield is above 85% in industry, we call that a success. We want to try to get it to as close as 100%. And so drug companies, anything that's using like paint companies, anybody who's using chemical to make a product wants their actual yield to be very close to their theoretical yield. It tells us a couple things. One, you weren't very wasteful doing the product, and two, you probably have a pretty good quality product. If your actual yield happens to be over your theoretical yield, ooh, big red flag. No, this is horrible wrong. If your actual yield is over your theoretical yield, your product is probably garbage. So, what does that mean? One, you definitely did not calculate correctly, or you measured way over the amounts of what you need, but it means you probably have some impurities in your product. This would be a huge red flag because if you're making things like, I don't know, drugs that people take to cure diseases, and you have an impurities in there, it could, not work. Or it could kill the patient. So that becomes a problem. But let's calculate some of these. So first off, this one is only giving us one of the reactants, which means we don't have to find the limiting reactant. If you're given both of them, you have to find the limiting, as we did last lesson. But this one, we're only given one, so we don't have to worry about that. So we're going to convert this into our product. So we want to figure out from sucrose how much ethanol we have. They already gave us the chemical equation. And is it balanced? It appears to be so. So we are going to take and go from a mass to mass conversion at this point. So we start with 648 grams of sucrose. We find the molar mass of sucrose, which is 342 grams of C12H22O11. Forgive me if I don't write all those. My handwriting is also horrible enough. So now we're going to go 1 mole of sucrose is equal to 4 moles of ethanol, C2H5OH. 1 mole of ethanol, that's not bad. That's C2H5OH has a molar mass of 46 grams. Multiply that out, you get a theoretical yield of 368 grams of C2H5OH, and that's ethanol. Now, you want that to be close to 100%. So they already tell us something here. We tell us if we actually ran this experiment, we obtained 349 grams of ethanol. Now, you can't just make that number up. That has to come from them. So how much percent yield do we have? So we take our actual over our theoretical. So in this case, our theoretical we just found is 368 grams. Our actual is 349 grams times 100. The actual they gave us, have to give us, is 94.8%. Now, if you go and talk to our ethanol plants, they're telling you that you run at 100% efficiency. And that is good, because then they're meeting their optimal amount of ethanol being produced, plus they're making the most profit margins that they possibly can. So that's good. All right, so now let's talk about this next equation. So upon heating, calcium carbonate decomposes to form calcium oxide and carbon dioxide. So let's write a balanced chemical equation. CaCO3 decomposes to form CaO plus CO2. Oh, we're balanced. Good. It says determine the theoretical yield. We're only given one product, so we don't have to find eliminate in this one. So we have 235 grams of CaCO3. We're going to do a mass-to-mass conversion here. So we look up the molar mass of calcium carbonate, and we have 100 grams CaCO3 over 1 mole. Again, that's the molar mass. We're going to do a mole-to-mole conversion. Well, this is easy. It's 1 mole of CO2. Well, we want to go to 1 mole of calcium carbonate. Now we can go, we've canceled all these out. We can go from moles of CO2 into our molar mass, because it's grams per mole for molar mass, which is 44 grams of CO2. I gotta arrow down a little bit. This would equal, multiply it out, 103.4 grams of CO2. This is our theoretical yield. So now it says, what is the percent yield? Well, that's our actual over our theoretical. So our actual yield they have to give us, is right here, our theoretical yield we determined. And so we have 97.5 grams over 103.4 times 100 grams. We are going to get a percent yield of 94.3%. Hey, that's pretty darn good. Again, you want to get as close to 100% as possible. Otherwise, you have some impurities or something that went wrong. If it's really high or really low, you did something wrong with the experiment. The product is probably garbage. Now, you'd have to do a chemical analysis to make sure, like things like the melting point would be one thing that you could do to make sure that you had the right product. But overall, if you have an actual yield that is either way above or way less than your theoretical, giving you a percent yield that is just not between 85 and 100%, something went wrong with the experimentation. And so you have to figure out where that error was. Was it in your measuring of your masses? Was it in how you conducted the experiment? Did you just have so much residue stuck to the side that it was just off? You got to be able to tell what's going on with that. And so make sure that you do determine that before going any further, because you probably have a product that's not any good.